Hi everyone. So someone of my students who I made those videos for asked me to go deeply in regards to clarifying certain things in the last proof. So let's see how can I clarify it. So, well, first of all, let's just consider the following set A, and the set A just contains 3 elements. If B is a subset of A, we want to know how many possible subsets there are. So, well, how can we construct such a B? So the question of asking how many subsets there are is the same thing as asking how many B's can we construct, and that is the same thing as asking how many elements or how many possible elements can we construct for a specific random subset B. So for each x inside of A, we have the choice of either including that the element or not. So that means that for each element we have 2 choices, and since we have 3 possible numbers where each have 2 choices, so then it would be 2 to the power of 3 possible choices that we can select things from for choosing specific elements. Or said it in a different way, for each x belongs to A, there's 2 choices for each element of A. So in total, there is 2 to the power of 3 choices of selecting particular sets of choices for constructing the subset B, including no choices at all. So it is 2 to the power of 3, which is 8. So in general, if we have a set A with n elements, then the possible number of subsets we can construct for A can be constructed by asking how many possible elements we could construct for a specific subset. So there is 2 choices for each element of A, and A has n elements. So in total, there is 2 to the power of n possible ways of constructing subsets of the set A. So the power set of A, the size of that is 2 to the power of n, where n is equal to the size of A. So don't worry about those things. You can see about cardinality as well as power sets, etc. I'll do a video in discrete mathematics. I'll do a playlist in discrete mathematics covering that in extreme details. So let's continue using that idea. So assume n is equal to a, b. We want to show that 2 power a b minus 1 is also of the form r times k. For r and k are proper factors of 2 to the power of ab minus 1. So let's do that. So notice here that 2 to the ab minus 1, this is the same thing as 2 to the power of n minus 1. So as we have seen, this counts the number of subsets that are not zero of a subset of n elements. So let's write n as a multiplied by b. So n really represents a rectangle, the area of this rectangle here, with columns of a and rows of b. So then we want to look at 2 to the power of n minus 1 properly. So let k be the column. So pick k to be the column of this rectangle, to whose left, to the left of k, we have certain configurations that are 0. So the reason I'm saying that is we can, as we have seen earlier, is that we can subdivide this area into a bunch of switches, being on and off switches, and we want to see how many possible switches there are. You want to count the total number of switches. So to count the total number of switches, we implement the following. So say to the left of a fixed column, k, we have the configurations is the 0 configuration, and at k, so we have the 0 configuration. And at k, we have the non-zero configuration, which has elements which has elements 2 to the power of a minus 1, as a is your columns, and to the right of k we have possibly 0 configurations. Those have elements 2 to the power of a, but since we have already counted k columns, so then it would be 2 to the power of a multiplied by raised to the power of b minus k. So then we get the following. We get 2 to the power of a minus 1 multiplied by 2 to the power of a raised to b minus k, and we sum up at all the possible k's. So k from 0 to b minus 1, and as you can see here, to b actually. And as you can see here, this really gets us the same answer. So I hope it makes more sense now. And yeah, I enjoy combinatorics. It's really fun once you analyze things from a geometric way. It's just I tend to see things in a structured way, and I like to I tend to synthesize more I tend to see the topological intuition first, and then from the topological intuition I get the other types of intuition. So geometric intuition kinds of plays a role into calculating the computations for me. So yeah, I hope you guys enjoyed the video, and I will see you in the next one. See you guys.